Okay, Edexcel Further Maths Core Pure 1 paper in June 24. This is the question 6, and it's a proof by induction. So straight away, I imagine there's quite a chunk of people that did this question and got 0 marks because they saw this, didn't read it carefully, or just ignored the fact that it says prove by induction and just went ahead and expanded all this out and used their sum to r squared to prove it, which you could do. But it specifically says prove by induction, so you've got to do the inductive method. So you start off the inductive method. The classic one is you consider the n equals 1 case. So consider n equals 1, very first case. If I put it in the left-hand side, it's going to be the sum from 1 to 1 of 2r minus 1 squared, which is basically putting 1 in there, 2 times 1 minus 1 squared, which is 1. And then the right-hand side is equal to a third times 1 times 4 times 1 squared minus 1. So basically putting 1 into the right-hand side. And we work that through and we get a third times 3, we get 1. So it's therefore true for n equals 1. So you've shown it works for the very, very basic case, the very first case. We're now going to make our assumption, and our assumption when we do induction, there's lots of ways you can do this. Assumption is this, assume true. Don't know why I wrote the assumption there, no need to, just need to write assume true for n equals k. So I go, right, I'm saying that when it's sum from r equals 1 to k of 2r minus 1 all squared, that's equal to this third k 4k squared minus 1. So assuming it's absolutely true for n equals k. We then look at the next case. So we say, right, consider n equals k plus 1. So we're looking at the very next case. Well, the sum from r equals 1 to k plus 1, now, because we're considering n is k plus 1, is basically the sum from 1 to k plus, oops, funny looking too, plus putting k plus 1 in there, because it's basically all the ones from 1 to k plus one more, the k plus 1 case. So we put the k plus 1 case in there, which is 2k plus 1 minus 1 squared. Okay, this is our assumption. So assuming it's equal to a third k 4k squared minus 1 plus this, well, let's sort it out a little bit. 2k plus 1, so 2k plus 2, take 1 is 2k plus 1, yeah. So it's 2k plus 1 all squared. Okay. No, that's wrong. No, that's right, sorry. I was just like, what am I doing there? Never mind. I'm correct. Right, okay. So, what we've now got to do is take that expression and turn it into something that looks like that, but with a k plus 1 instead of our n. Okay? So we've got to be a little bit careful here. And the first thing I can notice is that 4k squared minus 1 does factorise, because it's a difference of 2 squares. And one of it will be 2k plus 1 and 2k minus 1. So I'm always looking for things like that, a difference of 2 squares that can factorise. Now I don't know whether that's going to make my life a little bit easier, but I'm going to go with that, I think. So that's going to turn into a third k, 2k plus 1, 2k minus 1. So difference of 2 squares on that, 4k squared minus 1. And here we got 2k plus 1 squared. Okay, now then, I'll take the 2k plus 1 out then. And you know what, I'm going to take a third out, because I know I've got a third in my proof. So a lot of the time you just force out the result that you want. So I want to take a third out at some point. So let's just take it out now. Let's take out a third. Let's take out a 2k plus 1. I'm not happy about this 2k plus 1 because I know I need a k plus 1 there. not a 2k plus 1, but we'll come back to that. That'll be okay. And then what are we going to have left when we take that out? We're going to have that k. We're going to have a 2k minus 1. We're going to have a plus. Now, we've got to be careful here. If I've taken a third out, I've got to times that by 3 because there isn't a third to take out of this. So it's going to be a third of 2k plus 1 left over there. Hopefully that makes sense now. So the 2k plus 1's come out of there. I've forced a third out, so that's going to have to be a 3 there to compensate for that. Taking the third and the 2k plus 1 out, so I'm left with those. Boom. Now that looks like a quadratic when we multiply it out, so let's do that. Let's see what we get. 2k plus 1. Right, so I'm going to get 2k squared minus k plus 6k plus 3. Okay. Equals a third, 2k plus 1, right, so it's 2k squared plus 5k plus 3, right, factorise that, yes, that factorises to a third. Don't forget, don't spend too long doing your factorising because your graphic calculator will do some factorising for you. You know, you can find the solutions if you put that in equal to 0. Helps you factorise. So what we got, 2k and k, I've completely forgotten what I'm doing now. Oh yes, so plus 1 there and plus 3 there. That should be right, shouldn't it? Yes. So let's have a look. Oh, that's going to be a little bit of work to do on that, but we can do that. That's fine. So the good thing is, there's my k plus 1 that I can take out. I'm expecting a third k plus 1, there's my third k plus 1. So it's actually these two terms here that I need to sort out with this. So let's first of all take the third k plus 1 there, put that on its own there nicely. Right, so if I multiply this out, and sometimes you just can do this because you know what it looks like. If I multiply those two terms back out, 2k plus 1 times 2k plus 3, I get 4k squared. I get 6k plus 2k, 8k, and I get 3. I know what it's got to look like. I know I need 4k plus 1 squared there. So to be honest, I could just do this and just go, right, well, I know that's 4k plus 1 all squared. And when you multiply that out, I'm going to get 4k squared, I'm going to get 2k times 4, so 8k, so that fits, but I'm also going to get plus 4, yeah? So the plus 4 I don't want, those two terms become that, so I can take minus 4 plus 3, and that is therefore 4k plus 1 squared minus 1. Now that last step going from there to there is a bit of a, not a fudge as such, but you know what it's going to have to look like. And so it is quite a nice thing to just go, well, I know that's going to be my final answer. Just check that that actually works. When I take that out and when I multiply that out, it does actually work. Therefore, true for n equals k plus 1. And then you trot out your sentence, and don't forget your sentence. Or read. My advice on this is just, you must be looking at loads of mark schemes by now, I imagine, on these kind of things. Just almost copy out word for word their kind of wording on a typical conclusion on a proof by contradiction, and just use that each time. So their wording is, once you've established the n equals k plus 1, they just say, and as it is true for n equals 1, the statement is true for all positive integers n. But have that concluding sentence there. So, tips, I think, you know that third's got to come out at some point, so force it out as soon as you can. Okay, look for factorising somewhere. I could have done this possibly a bit neater, but it worked out nicely for me in the end. But forcing out a third straight away helps you know, right, what have I got left to deal with? Okay.